Olivier Marlet, and I'm a research engineer in archaeology in Tours, France, and I lead the Huma-Num consortium MASAplus, and we're going to present the workflow we've set up with my colleague Florian Hiver to help archaeologists to bring their data to the semantic web. The Huma-Num consortium MASAplus has been running from 12 years, and its mission is to support archaeologists in digital best practices. As part of an open science policy and in line with FAIR principles, the mission focuses more specifically on enhancing and enriching data so that it can be shared and exploited on the semantic web. To this end, MASA has set up a digital ecosystem that you can see here, based on the data life cycle to satisfy the requirement of researchers at different stages in the life of a research project. This digital ecosystem includes pre-existing open source tools on which MASA relies, and other tools that MASA has developed to support the needs of the community. There are several prerequisites to bring data to the semantic web: data cleansing and homogenization to simplify the automation of alignment steps and ensure consolidated data, alignment with standardized vocabularies to disambiguate them and make them interoperable, semantic modeling with an ontology to structure the data in a triple store according to the common CIDOC standard, and putting data online so that it can be accessed as a resource. Yeah. Here is an overview of our workflow, highlighting the tools we use. We're going to explain each step in greater detail for more complex ones, especially those involving the CIDOC. The first step is data cleaning. For this first step, we're using OpenRefine. It's a free multilingual tool that's easy to install and has numerous tutorials to help you learn how to use it. OpenRefine loads data from tabular formats, SQL database, Postgre, MySQL, SQLite, or XML files. Data is processed as tabulated files. You can view all occurrences of a column as facets and automatically act on the entire column according to these facets. OpenRefine is particularly powerful for cleaning, homogenization, and column transformation, like splitting, merging. We encourage all of those who use Excel for this kind of processing to discover OpenRefine for processing their data. OpenRefine is also powerful for data enrichment with web services. In this example, we've got some archaeologist name in our source array, comme Camille Delacroix, and we can first use a Wikidata web service to match the author column with Wikidata. Next, we enrich our data with the archaeologist's birthplace. This data comes from Wikidata, and it's imported automatically thanks to the links between our data and Wikidata. And from the imported place name, we can use the GeoNames web service to collect the coordinates, and if you want to map our data with latitude and longitude. The GeoNames web service allows this with a free account, but limits the number of requests we can make per day. So if you want to process a lot of data, we can import the entire GeoNames repository, country by country. We can then load the GeoNames repository as a new project in OpenRefine, then cross-reference the two projects using the ViBytes extensions. We indicate that we're linking to the place name and obtain the coordinates. In this case, the interoperability proposes we can collect GeoName persistent identifier at the same time. Finally, we also use the Pactol's web service provided by OpenTeso. We could have recovered place information in this way, but we use it for this purpose with the correspondence type column. In this way, we collect the persistent identifier of the pactols for terms that match the repository. There are also more complex methods for selecting among different choices in the repository when there is a risk of homonymy with polysemy. Tutorials are available on how to do this. Once the data has been consolidated, the second step is to enrich them with standard vocabularies. The advantage of aligning our vocabularies with normalized repositories is both to disambiguate them and to make them interoperable. Here again, OpenRefine is a powerful tool. OpenRefine uses the web services of several repositories such as geonames and pactols. This makes it possible to enrich our vocabularies with persistent identifier for concepts from these repositories. Here is an example of the benefits of this disambiguation and interoperability step. In the first step, in the first case here, we have different character strings referring to the same concept. In this case, Sanctus Martinus and Saint Martin. How can we be sure that they refer to the same concept? In the second case, we have similar or even identical character strings referring to different distinct concepts. In this case, a person and a place. How can we be sure that we're talking about a place in one case and a person in the other? The solution is to use the URIs of this concept defined in standard repositories. This enables to refer to a concept without any doubt, without depending on a particular language. The vocabulary of our datasets is aligned as far as possible with standard repositories. For thematic, physical, or conceptual vocabulary, we use Pactol's theory. Pactols are themselves aligned with Getty's IAT, which is widely used internationally, particularly by Ariadne+. For localization, we use geonames, which provides several web services for retrieving various information, including latitude, longitude coordinates. For dating, we use a periodogazetteer, especially for metadata, since our data often includes dates that are more precise than periodo periods. Finally, for author, we use IDREF and the VIAF, which references all authors. All these repositories provide persistent identifiers that refer to the concept. The use of these repositories, which are widely used by our communities, make our data interoperable. MASAplus supports the Pactol's multilingual thesaurus, which is highly suitable for archaeology. Pactol's is managed with the thesaurus manager OpenTheso that you can see here. It's an open source tool for structuring a thesaurus and publishing it on the web in association with many web services. The third step is to publish the data on the web. This step is essential since it will restore user resources. Each element of the dataset must be accessible as a resource. This means that each element must have its own URI. We're not going to detail all web publishing methods here. In the Huma-Num consortium MASAplus, we have many different cases, of which here 3 typical examples. A corpus published in XML for IRBA, corpus structured in an online relation database, and a corpus from tabulated files published as a static HTML website. The choice of static HTML format concerns data tables that will not be modified. An automatic workflow produces web pages for each resource without a database. This solution works without a particularly power-hungry server and is more in line with energy-saving issues. In all cases, the important thing is to have a specific URI for each record so that it can be located as a resource. The next step is probably the most complex. It involves the CIDOC ontology. The CIDOC structures cultural heritage information to make it accessible on the semantic web. For the MASAplus Tropile Store, the objective was not to set up a system that would have precisely modeled all the datasets. This would have resulted in a level of complexity that was incompatible with unified, easy-to-query access. For OpenArchaeo, we therefore decided to implement a generic model mobilizing the most commonly used concept in our archaeological datasets. Some datasets mobilize all of them, others only a few. In all cases, the source datasets are richer than the data we have decided to display in the Tropile Store. A Tropile Store can therefore be seen as a catalog. This catalog enables information to be found quickly and by accessing the resource to access other information specific to the dataset. For example, OpenArchaeo doesn't model the weight of coins or the orientation of a burial, but it can find coins and burials. Online resource will provide access to more specific information. In this simplified version of the generic model, you can see the main concept used in CIDOC. Most are taken from a CRM base, but we also use encounter event from CRM Science for discoveries or operations, stratigraphic unit from CRM Archaeo, and built work from CRLBA. Each of these generic archaeological concept is described by an identifier, a name, a descriptive element, or a typological resource descriptor. Each of these concepts can also be associated with documentation, like a bibliography, photography, record sheet, drawing, plan, and so on. And of course, each concept can also be dated. It could be for the excavation, for artifact, stratigraphic unit, feature, structure, site, and document. Each concept is identified by the URI of its resource, and each typology uses the URI of the concept it refers to in a repository or gazetteer. It's on this detailed generic model that we can base our dataset mappings. Our archaeological colleagues have often reproached us for the complexity of the CIDOC. Fortunately, several years ago, George Bossiker and Anaïs Guilhem designed a card game to help understand how CIDOC works and to familiarize users with the mapping process. Each CIDOC entity and property is presented in the form of card with the information needed to understand it. A color system is used to check the validity of a property between two entities. And finally, instances are also presented in card and can be associated with entity card representing the mapping. A print-ready PDF version is available for download at the address indicated in the bottom of the slide, and the script is accessible on Huma-Num GitLab. MASAplus has also produced a dematerialized version of the card game called the Onto-Match game. This fun learning version is divided into several levels. The first is for discovering how an ontology works. The second one is for discovering how the CIDOC is structured and the branches which constitute it. The third step is to discover mapping by associating instances with entities. In this version, the board can manage the equivalent of two tuples using 3 entities and 2 properties. A new version has been available since last week. This is a prototype of a freeboard version, allowing cards to be fully deployed in the same way as with the printed deck. This version offers the possibility of building a complete model without limitations. For the moment, however, this mode does not automatically check the validity of properties between two entities. And this is left to the player to control. We encourage you to suggest this game for the searcher who you work with to help them familiarize themselves with the CIDOC. Now we have a robust semantic model on which to base our mappings. The next step is to use this model to generate triples. Until now, we've been using two tools to transform our data into triples. Firstly, the well-known 3M, which transforms XML data into RDF triples. However, most of our data is not in XML, but in relational databases. In this case, we use Protégé, the free software for creating and exploring ontologies. By adding the OnTop plugin, we can dynamically connect the ontology to a SQL database. OnTop is also free and developed by the University of Bolzano. We recently came across a new solution for data tables in Excel or open document spreadsheet. Of course, we could have we use OpenRefine, so we could export this spreadsheet in XML or SQL, but OpenRefine also allows us to produce an export template. We were therefore able to create the mapping models to produce RDF triples directly from OpenRefine's export module. This solution minimizes the number of steps involved, but offers no syntax control like 3M or OnTop. When data were produced with OpenRefine, we saw that it was possible to export them in other formats. In this view, we have a header zone for defining prefixes and also elements that will not be repeated, which may correspond to the file's metadata information. Below, we see the template for processing a table row in RDF format. The export module then reproduces this template for each row. In this way, we can directly export the contents of our table in RDF. If our datasets contain several tables, we can simply merge them into a single RDF file. Now we have our RDF file with all our triples. However, it would be an illusion to think that we can publish it just as it is. In fact, our file may contain syntax errors, data errors, or relationship constraints that are not respected. It is therefore essential to subject it to validation check. The Sparql Play tool is used to check our triples. It compares each triple with the data models we have produced previously, the OpenArchaeo generic model. Any errors detected are then analyzed to enable the correction of the triples. Single errors may reveal problems in the datasets itself, but badly from that, or a missing information, for example. A mass error, which concerns all occurrences of a dataset, may indicate a syntax error in the mapping. And this could be, for example, the use of a wrong property or a mandatory object missing from the dataset. Finally, if the data is correct and the mapping is good, the error may also reveal a failure in the semantic model itself. So the more the different datasets we submit to Sparql, the greater we will improve the robustness of our ontological model. This step may therefore require going back to previous steps to correct errors before resubmitting our RDF to Sparql. The next step is to publish our dataset in our MASAplus triple store. We won't go into detail here as it depends on your technical choices. We choose the free version of GraphDB, which can already be used to deploy a large number of datasets. The publication of triples in GraphDB is well documented and doesn't need to be discussed here. We think it's more interesting to focus on the last step of our workflow. We think we've implemented a particularly powerful tool for exploring the data in our triple store. Let's take a closer look. When we set up a triple store, we naturally provided a Sparql endpoint to query data. To facilitate learning the query syntax, we proposed a few pre-recorded queries. However, we realized that we wouldn't be able to bring along our archaeologist colleagues who are not at all familiar with this highly technical language. And if they can't explore their own datasets, why make the effort to deploy them in the semantic web when it's easier to open a database, read an XML file, or explore a data table? It was essential to find a solution to this problem, since the semantic web will be more effective if the whole community is mobilized. We were inspired by the British Museum research space system for querying its collections. This system proposed to set up a query based on the CIDOC model underlying the data. The system we have set up with Sparna is called Sparnatural and goes beyond the CIDOC model. Indeed, the system is already a great step forward for querying a Sparql without knowing the syntax. However, we've gone a step further for proposing other improvements, in particular the use of concepts used by archaeologists rather than the corresponding CIDOC entities. Here we can see the home page of the first version of OpenArchaeo. A second version will be available very soon, with a few archaeological datasets. Each dataset is described with metadata to facilitate filtering. Sparnatural is a system of icons to identify the main components of the archaeological data: the site, the operation manager, the archaeological structure, the archaeological feature, the wall, the burial, the stratigraphic unit, and the archaeological artifacts. Sparnatural automatically matches this concept with CIDOC entities to build the Sparql query. We start by selecting the entity for which we want to get an answer. Here, I'm interested in burials, for example. Then OpenArchaeo suggests either questioning directly the criteria of these burials as its dating or investigating entities directly related to the burial entity. From the generic model, Sparnatural then proposes concepts that are directly linked by a property to the selected concept. When users connect two elements, burials and site, for example, Sparnatural automatically suggests the available relationship between these two entities found in this case. This enables users to formulate their request in a simple way without having to know either the entities and the properties of CIDOC CRM or the structure of the system. We can then either search for an entity by its appellation or continue to associate other entities. The appellation search is done by dynamic drop-down list of available occurrences. Here, I have selected the archaeological site of Marmoutier, but we can also decide to focus our question on a criterion carried by another entity. Here, I'm interested in persons who have been in charge of the excavation. And the person I'm specifically interested in is Elisabeth Laurence. Well, that's it. Where my request is built, I'm looking for burial found in a site which is studied by an actor called Elisabeth Laurence. It looks like a sentence that is readable and understandable by an archaeologist and even by ordinary people. The Sparql query that correspond to the sentences visually built by users are automatically computed. Thus, the user does not need to know the underlying model of the Sparql query language. The results of the query can be displayed in several ways. Here, a table giving the URI linking to the online resource. In the case of a located thing site being queried, it's possible to display the result as a map. The results are clickable, the links to online resources, providing further information if required. In this case, the second link is to a burial record as at Marmoutier Abbey near Tours. This is the complete workflow that MASAplus has implemented over the last few years using free or open source tools. These tools have been registered as resource in Daria SSH Open Marketplace. This platform enables researchers to document and share each of their online resources, software, tutorials, articles, bibliographies, datasets. And secondly, in the SSH Open Marketplace, we can also document the whole workflow, identifying which resources are mobilized step by step. MASAplus has therefore published this workflow by bringing datasets to the semantic web on the SSH Open Marketplace. Anyone can reproduce or adapt our approach. We encourage anyone new to the SSH Open Marketplace to try it out and upload their own resources and workflows to share with the community. So thank you for your attention. I will now let Florian show you the new version of Sparnatural for OpenArchaeo. Then we'll answer your questions and discuss this workflow and tools. Thank you.
Hi everyone. So despite what Zoom is displaying, I'm not Olivier Marlier-Thiou. I'm Florian Hiver from the MSH Val-de-Loire in Tours. So I'm a web semantic web engineer. And I worked on OpenArchaeo for 4 years now. I did all the mappings of the dataset that you will see, or you already seen in the slide previously. And I also worked recently, since 1 year actually, on a new version for OpenArchaeo, which is accessible by the way, but hidden in the repositories of the OpenArchaeo site, like OpenArchaeo v1. So you can try it actually and break it if you want. It will help me a lot to break the site actually. The whole principle of the second version of OpenArchaeo was to follow the update of Sparnatural, since OpenArchaeo first version was made was like the prototype of Sparnatural, and the Sparna Society then produced a Sparnatural that they update every now and then with new functionalities. And we couldn't update these new functionalities inside the old version of OpenArchaeo. So we did a new version. And some of our reflections that came from time to time were put also in this new version. You can already see in the home page that we still have the Explorer that I will show it after, because there is a few change too. And we have access to a catalog, because before we were updating the dataset on OpenArchaeo, but OpenArchaeo was not considered as a catalog in itself. And we changed that because now the whole site is described as a catalog, like semantically, and each dataset are described with the Decat ontology as dataset, as it is in the Decat ontology. So I enter a bit into details, but what what I could resume all that in is just like there is metadata on the OpenArchaeo catalog, and for the dataset, we are a bit more standard than we were before. We can already see that, like on the homepage, we speak about the model, we present it, so you had the presentation just before, so you don't need it, but it's important to show the model to people, to query it a bit more with intuition. The Explorer, so I don't see my, like, it's loading. I hope nothing is breaking. So the Explorer, before we had to go from a first page to select all the dataset that we wanted to query. Now the dataset that we want to query and the Sparnatural just below are on the same page. Before it was two distinct pages. So when you wanted to add another dataset or remove another one, you had to go back in the previous page and redo your selection of dataset. So now they are all on the same page. You can see I have a small button to select, deselect it, and I can select what I want from there, and etc. They are also described in these little accordion elements. In this accordion, we just stuck on the main metadata that are interesting to query the dataset. So you have the source of the dataset, the period of the dataset, the period in concept 2, so numeric and concept, the place described in the dataset with geonames, and the few keywords of the dataset that are provided by the publisher when we talk about putting the dataset on OpenArchaeo. There is also a page show more that we can already go if you want to. So the show more page is more like a fully described page on the dataset with issued, modified, creator, publisher, and the same data that we saw just before. There is also two buttons that are not working for now. This will be an upcoming thing in a few months. There is a description of what is in the graph, actually, like what entities are mobilized inside this particular graph. And you can download also the whole graph with its description, or it is what we want to provide in the next month. Also, compared to OpenArchaeo before, now when you go on the dataset page as this one, you can query only the dataset. For the moment, you have all the entities of the OpenArchaeo model that are provided to the user to query, but some of them are not in the dataset. So one of the next step also will be to show only the entities that you can query inside the dataset. So you don't have like a null query or empty query as a result, because it can be really bad for the user as an experience to query something, build a query, and have no result at all. So let's get back to the Explorer a bit. The Explorer, so as Olivier mentioned before, is using Sparnatural. We stuck almost on the same entities in the new version. So you have the artifact, the archaeological site, excavation, wall burial, archaeological feature, stratigraphic unit, etc., etc. And you can build your query as before by selecting some relationships. So here I will search all coin, for example, and I will also want me that the site is provided when we found some coin. And so here, for example, it will show me the artifact resource that is a coin and the archaeological resource that found or that contained some coin. So let's launch the query. Actually, if this one, the curse of the of the video conference, like so here you can see we have some URI to the Arcel website, and here we have the site of these the URI of the site, just aside it, but the results are limited to 1,000, and actually there is a lot of coin in Arsol, so you can see only Arsol is displayed. So I will just cut a bit Arsol from the mix and redo my my query. So every time you remove or you add a data set, it will reset Sparnatural, so you have to redo your query. But it was also because it was hard to dynamically um, add the dataset inside the Sparql query. And sometimes I saw that when you select another dataset, you will want to do another query, not specifically the same that you did previously. So Sparnatural reset every time you select a new dataset. Here we have other objects you can see here, and we can go on the website actually. If Zoom wants me to see my screen here. So here it's the dataset AR bar, which here display the information in French on the site. And actually, it's important because the two URI go on the same page, actually. But since in the text there was a mention on a coin that were found on the site, I decided to guide the user on the same page, but it's not semantically the same URI actually. But they are mentioned on the same resource page, so for the user it was better to bring him on the same page actually. So for further details you can ask me, but it was the idea behind. Actually, there is also a new page here where like I said, the OpenArchaeo catalog is a bit more described. Actually, we don't display a lot of info on the catalog page because there are a lot of technical information and metadata. For example, like the metadata that describe the catalog, like the keyword, are compilation of all the keywords that are describing the dataset. So it's like not necessary to repeat like all the keywords that are present in all dataset on this page. The catalog should be also provided to the user as a resource in JSON LD. It's not the case again for the moment, but it will come in the few months after this presentation. And you also have like a filter system to select your dataset. So here you have all the keywords that are describing the dataset. And if I click on this one, you can see here I only have the dataset that are attesting to me on the keyword. By the way, the keyword are Getty. Like it's Getty, the concept from Getty and the label from Getty. So yeah. I can do the same with the period, for example, and I can do the same then with the places. And you can see here I have two datasets. I think I showed everything. we still have the Sparql endpoint that is existing. If you want to do some Sparql query, you can. And there is still the queries that are pre-done, like, and provided to the user to see a bit like how you can query the dataset. And you can see here also the endpoint of the triple store that you can, by the way, use on any Sparql querying system actually, if you provide the endpoint. I think I'm done.